Now I want you to make a prediction. In my left hand, I have a standard-sized basketball, and in my right hand, a 5-kilogram medicine ball. If I drop them both at exactly the same time, which one will hit the ground first?
Ah, this is a trick one, isn't it?
The heavy will go down first.
Well, yeah, it'll drop faster.
They'll both hit the ground at the same time.
Give me a prediction.
I actually would have thought this one would go faster because it's heavier.
Maybe it's that one. Maybe this one, yeah.
So you reckon this will be faster?
I reckon that one will be faster.
So why does that make it go faster?
Because the weight pulls it down quicker.
What are we measuring when we say, oh, it's heavier? What are we feeling?
Gravity?
Go ahead. Yeah, that's... Ooh.
Objects being pulled to the earth, I guess.
Okay, so which of these objects is being more pulled to the earth?
This one.
That one, the black one.
All right. Well, here's what we're going to do. I want you to hold both of those above your head. Don't worry. Can you get them really high? Can you? Okay, on the count of 3. Ready? 3, 2, 1.
Yeah! Exactly the same.
Oh, they fell at the same time. Exactly the same time.
They hit at the same time.
Was that what you expected to see?
No.
So what do you make of that?
I need to go read more books.
Magic?
Gravity is going to pull at the same rate, no matter how heavy or how light it is.
There must be some force that's dragging them down, and actually the actual weight of it doesn't matter.
Consider the acceleration of a bungee jumper. When does he experience the greatest acceleration? Is it A, immediately after leaping off the platform? B, when the rope becomes taut? C, at his fastest point? D, at the very bottom of the jump? Or E, on the rebound? Make your selection now. As a reminder, A is just after he leaves the platform, B, when the rope becomes taut, C, at his fastest point, D, at the very bottom of the jump, or E, on the rebound. Congratulations! You chose the correct answer, D. The bungee jumper experiences maximum acceleration at the very bottom of the jump. This is a counterintuitive idea for most people because they confuse the concepts of velocity and acceleration. At the bottom of the jump, the velocity is virtually zero, but acceleration is not. So what is acceleration? It is the rate at which velocity changes over time. It is very difficult for us to spot just by looking at it because our eyes track motion smoothly. So you have to think about the velocity at 2 different times. Right before the jumper reached his lowest point, he was going down, but after he reached it, he was going up. So while he was right at the bottom, his velocity was changing rapidly. In other words, while velocity was minimal, it was changing at the greatest rate. The key is to keep the two ideas separate, velocity and the rate at which it changes.